Hey everybody, in this video we're going to be practicing equations of normal lines. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. Now, tangent lines and normal lines are found almost exactly the same way. The only difference is that normal lines are perpendicular to the function, whereas tangent lines are parallel. So we would follow the same approach in that, given the x value, here we have x equals 1, we're going to find the y value that corresponds with that. So y equals 1 cubed minus 1 squared minus 2. So that should be a y value of negative 2. So secondly, now that we've found our y value, we need to know what is the slope of the function at that point. So our derivative, dy dx, is equal to 3x squared minus 2x, and the minus 2 just disappears. So when we substitute negative 1 in, the slope is going to equal 3 times 1 squared minus 2 times 1, and so that equals 1. However, that's the slope of the function, and with the normal line, we want the slope that's perpendicular to that. And so perpendicular slopes are always opposite reciprocals. So perpendicular slope is going to equal negative 1. And the one key way of remembering whether two numbers are opposite reciprocals is if you multiply them, you should get negative 1 as the result. So let's write the equation now. So in point slope form, it's going to be y minus negative 2, because that's the y value we found up here, equals negative 1 times x minus 1. And we can simplify that to y plus 2 equals negative 1 times x minus 1. The plus and the minus combine to make it y plus 2. So to write this in slope-intercept form, we multiply everything by negative 1 first. So y plus 2 equals negative x plus 1, and then we subtract the 2. So y equals negative x minus 1. And there it is in slope-intercept form. And this is the equation of the normal line. At this point, when x equals 1 and y equals negative 2, it intersects the function at a right angle to the slope that the function is following at that point. Okay, so let's move on to the next one. So here we have y equals 2x minus 8 raised to the 1/3. So first we substitute 0. So we have y equals 0 minus 8 to the 1/3. Now raising something to the 1/3 power is the same as taking the cube root. And so the cube root of negative 8 is negative 2. Next, we need to find the slope. And so this is going to require chain rule, because what we have is we have a function outside. That is, we're raising this to the 1/3, and then we have a function inside. So the outside derivative is 1/3, and then we leave the inside alone, 2x minus 8 to the negative 2/3. And then we multiply by the derivative of the inside, which is 2. Now we don't really have to algebraically simplify this, because we're just going to go right ahead and substitute 0 in for x. So 0 minus 8 to the negative 2/3 times 2. Now here we're taking negative 8 and we're raising it to the negative 2/3. And so what's happening is the 3 on the bottom means we're taking the cube root, but then we're also squaring it. That's what the 2 on top does. But we're also taking the reciprocal. So when it's all is said and done, we have negative 2 after we take the cube root, positive 4 when we square it, and then we get 1/4 when we take the reciprocal. And so 1/3 times a 4th is a 12th, times 2 is 1/6, and that is our slope. But since we're finding the normal line, we want the perpendicular slope. And that's going to be negative 6. That's the slope we want. So our equation then is going to equal y minus negative 2 equals negative 6 x minus 0. We can simplify this here and simplify this over here. So y plus 2 equals negative 6 x. And then to make it slope-intercept form, we subtract the 2. So y equals negative 6x minus 2. And there it is in slope-intercept form. All right, let's move on to the next one. For this one, here we have y equals ln of x plus 4, and we're substituting in negative 3. So first we'll substitute in that value. So negative 3 plus 4 equals ln of 1. And anytime you plug in 1 into a logarithm, it always gives you a value of 0. So next we want to find the derivative. So dy dx equals, now again we have chain rule. The outside function is ln, so that means it's 1 over x plus 4. And then the inside function, x plus 4, that derivative is 1. And so now we substitute negative 3 in. So negative 3 plus 4, and we get negative 1 as our slope. But that's the slope of the function, so we want the perpendicular slope. And so that's going to be positive 1. So our point slope form for our normal line is going to be y minus 0 equals 1 times x minus negative 3. And so when we simplify this, what actually happens is this becomes x plus 3. And so it's also simplified as slope-intercept form. For the next one, here we have this equation, y equals negative sine of 2x, and our point is negative pi over 2. So negative sine of 2 times negative pi over 2, so that's going to equal negative sine of negative pi. Now sine of positive pi is 0. And so making it negative means it goes in the opposite direction. So actually, sine of negative pi is also 0. So now for our derivative. Here we're going to have chain rule again because our outside function is negative sine. And so the derivative of that is negative cosine 2x. And then the derivative of the inside is positive 2. So when we substitute negative pi over 2, our slope is equal to negative cosine of 2 times negative pi over 2 times 2. So we have negative cosine of negative pi times 2. Now, cosine is an even function, so actually that negative on the inside is irrelevant. Even functions allow us to disregard any negatives. And so with the pi, cosine has a value of negative 1 times 2. Now we can't forget that negative out front, which means when we simplify this, we get a value of 2. And so our perpendicular slope is going to equal negative 1/2. That's going to be the slope we use for our normal line. So our equation is going to be y minus 0 equals negative 1/2 x minus negative pi over 2. Now since we are subtracting 0, I could have just written y equals negative 1/2 quantity x plus pi over 2. And if I distribute in the 1/2, we get negative 1/2 x minus pi over 4. And there is our equation in slope-intercept form. All right, looking on to this last problem, here we have the value of x equals 5. So we plug in 5 in for x to get our point. So 1 over 1, which is 1. To get our derivative, I think the easy way to do this one is to treat this as quotient rule. So low d high, so x minus 4 d high, which is 0, minus high, that's 1, d low, which is also 1, all over low, low. So that's x minus 4 quantity squared. And when we simplify this, we get negative 1 over quantity x minus 4 squared. So now we find our slope of our function at this point. So negative 1 over quantity 5 minus 4 squared. So that's negative 1 over 1 squared. So we get negative 1. So our perpendicular slope is going to be positive 1. That way, when they multiply together, we get negative 1. So our equation is going to be y minus the y value, which is 1, equals the slope, which is negative 1, times x minus 5. Now this is what it looks like simplified in point slope form, but we'll also write this in slope intercept form. So we multiply in the negative 1 on the right. So negative x plus 5. And then we add 1. So y equals negative x plus 6. And there we go. That's our equation of this normal line. Thanks so much for watching. If you liked the video, please give a thumbs up. For more videos like this, click the subscribe button. If you're a teacher and this helped, please share this with your students. Or if you're a student and this helped, please share with your classmates. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the only way to understand something is to do it.